Welcome to Update 3 of our project, Emotion Based Music Recommendation Chatbot. This project is integrated with Spotify dataset, Go Emotion dataset, which we use it to make a chatbot to give a playlist according to the user mentality. Murli, can you go to next slide, Murli?
Yep.
Our chatbot is designed to detect a user emotion tone from their message and recommended a set of songs that align to the emotion. We approach this training using NLP model that emotion to the best fit of the musical attributes from the Spotify dataset. So essentially, we are building an end-to-end multi-mode recommendation system. Uh, in next slide, yeah. The Spotify dataset has more than 1 lakh of data rows like variance, energy, danceability, tempo, and accuracy, which we usually use these columns to detect the emotion or calculate a emotion. These features are derived. These features are derived from using digital signal processing techniques. For example, variance is flat between 0 and 1, indicating emotional positivity, and energy reflect the song intensity measured from aspects like amplitude and speed. According to the values, we have created a column in the Spotify dataset to retrieve the emotions. In this future selection, we explore the distribution and correlation of future using visualization like histogram and correlation matrix. While futures like mode and key showed very little variance with respect to emotion, variance, energy, and danceability showed clear separation across genre and moods. This insight helps us for pure, less, and informative emotion recommendations. In next slide, to confirm our observation, we trained several classification models, including random forest, logic regression, and decision tree, to predict course emotion categorized based on futures. Using future importance scores this model, we consistently saw the value, energy, and discernibility were top predictors of emotion content. We removed low contributing features such as mode, tempo, and loudness. These dimensions reductions help improve the performance of the accuracy. From here and then, my friend Yogita will continue this presentation.
Thank you, Sanjay. After ranking all the audio features based on the model importance and statistical correlations, we finalized three features, which are valiance, energy, and danceability. Valiance indicates the emotional positivity of a song. A value close to one reflects a happy or cheerful vibe, while a value lower tends to indicate sadness. This is most directly emotion linked feature in the Spotify dataset, whereas energy reflects how intense and loud a track feels. Songs with high energy and often include fast tempo, dynamic vocals, and louder sounds, which are typically associated with emotions like excitement or anger. Whereas danceability measure how easy it is to dance to a song based on beat, strength, tempo, and rhythm regularity. Higher values often indicate songs that are uplifting or fun. We have also used KDE, kernel density estimation plot, to visualize how these features are distributed across different emotion labels. This distribution showed clear uh, separation. Next slide is about classifying the emotion behind user message. We used Google's Go Emotions dataset. This dataset contains 58,000 Reddit comments, each labeled with one or more emotions from a set of 27 grain categories, including joy, anger, gratitude, sadness, and more. We fine tuned the birds. based uncased model. Using this data set, each text input can have multiple emotions. We treated it as a multi-label classification problem using binary cross entropy loss. We also trained model in PyTorch for 3 to 4 epsilons using mixed precision to reduce training time. Our model achieved good F1 scores, particularly for dominant emotions like joy, anger, and sadness. The next slide is about the richness of Go emotions comes from its 27 emotions category, which include joy, love, admiration, approval, anger, annoyance, curiosity, confusion, fear, surprise, and many more. However, using all 27 categories directly in music matching would be impossible. Many of these emotions overlap semantically or have minimal distinction when it comes to music alignment. So if we clustered them into broader groups to make emotional matching more practical and for the chatbot. So the next slide will be about emotion group mapping. Here is how we approach the mapping. We manually group the 27 emotion labels into six broader emotions categories based on similarity and musical alignment. This made it easier to bridge the gap between text emotion and Spotify audio features. In the next slide, there will be the examples of how we match them. For example, admiration uh, and warmth are mapped into approval and caring, whereas annoyance, and disgust are mapped into anger and frustration. Sadness, disappointment are mapped into fear and sadness. So, by doing this, we made it possible to take Bird's predicted label and directly filter songs from the Spotify dataset that match the emotional tone. Next, my friend Vamsi will continue the presentation.
Yeah. So the next slide goes about defining emotion rules with the logic. So Murli, can you go to the next slide? So there we created a class. We classified the emotions into using the tracks explained by Yogita previous slide. So valence, energy, danceability are the main features we have. There are significant variables, and then we map it tracks to one of the six emotions accordingly. And then we also used like high valence plus high energy is like a joy and affection. So the balance is about how happy the song is. So and the energy is about how inbuilt energy you have, and then if it is a danceable song or it's not a danceability song. So for example, if you go with exploration, you have a balance of 0.5, which is midway happy, and then energy of 0.5, which is midway. So you are curious about song, or you are inciting about song because you don't have any danceability in it. You are just exploring a song, a new song. You don't have any emotion, regardless of because you don't. Maybe it is a new song for you like that. And then you are if you go for a fear, you have a valency of 0.3, which is very less. That is a low happy, and then which is energy. You have a mediocre energy of 0.4, and which is also less. So you are very, and then danceability is also very less, 0.4. So you are now in sadness. So you don't actually want to sit. So this is the way we classify the songs using these three variables. So we manually tuned all these ranges based on the percentiles and visual inspection of song clusters. So next slide, we have function implementation. We implemented using a set of nested if else rules, and then we applied row-wise to Spotify data frame, and then which actually returns one of the six emotion group labels. This column is then used to match with the BERT output which we got during the Go emotion data set. So the next slide is about Spotify emotion distribution. So the results classifications are of 106,000 tracks, which where we have classified the six emotions with appropriate number of data points, which are actually very uh, considerable data points that are there. So to and then we visualize shows the number of tracks per emotion group, and then our sample outputs include to begin again mapped with admiration and warmth. Say we can say something, say, and then go to the next slide. So does these sample outputs like to begin again? It says like admiration and warmth, and then it is Bebno core. This is like a neutral emotion you get. If you are say something, it is like about say something in fear or sadness. Just this is the way the sample outputs are, and the next slide will be continued by Murli. The mic is off.
Sorry, Vamsi, thank you. The final integration plan is like we will send the input text into BERT model. And as you know, from the emotion dataset, we'll get the emotion from the BERT model and we'll map that emotion in from the Spotify data. So, we have worked on the Spotify data and we figured out like which variables are important to find which emotion we need to give for which song. So we found out like valence, energy, and danceability are the important features from the dataset. And we created a column as Vamsi and Yogita told. So we will map this bird emotion to that Spotify emotion and we'll match them and we'll return the song which we got like for which the emotion is. So like for example, there are only six emotions, but each emotion as you I've seen in the previous slides, like, let me show you. You can see like 47,000 or 27,000 songs for joy and affection. So we'll randomly select a couple of songs and present them with the songs. So like that, yeah. And the next slide is like the architecture of the chatbot. So as I said, like, we are taking an input of a statement to give into BERT model. So basically what this chatbot does is like, it is the one which connects the BERT model to the user. It will just take the input from the user and it will give the input to the BERT model. So after this, you can see that input will go into BERT model and it will use the music mapping layer, which we have discussed now. It will select the chat and again the final output will come into the chatbot, which presents the output to the user. So if the user like wants to hear, he can hear or he can continue the conversation. He can ask one more, like he can chat more and he can get new conversation like that. So the future work we are thinking is like, no, we would like to improve the matching across datasets. So, we have created a good amount of uh, uh, boundaries for the each emotion, and we would like to work more on the boundaries and figure out which songs are mainly connected to which emotion using the Spotify dataset. And we'd like to take some real-time feedback from the users and learn how they are reacting to the songs and all. So like we are also thinking about like working on the voice-based emotion detection and face-based emotion detection. So this will be the extension to our project. So if we have time complexity, like if we have more time, then we can work on those things also. So for now, we have working on the chat, but in coming 1 or 2 weeks, we'll try to figure out like if we can create any links between the voice and chat, or links between the face detection and chat, like just replacing the BERT in place of other things. So we will try that. And conclusion for this, like we selected Spotify futures using ML and statistical analysis as we have discussed before. Like, and we used BERT model to like get the emotion from the Go emotions data, mapped both data sets into a common emotional space, like grouping emotions. As you'll see that six emotions we have derived from the both data sets. So like we built a system that connects users' feelings to the emotionally aligned music. So the pipeline you have seen before. So that's what we did. That's it. Like this mainly lays the groundwork for an emotionally intelligent chatbot. So yeah, thank you.